I was not able to speak at the wheat show last year because of my schedule. But if I was going to speak last year, I would have said that I do believe most areas we're going to see a dry 2020 and a warm 2020. And the thing is, this was Bismarck through June 26th. And I know this wasn't the case for everyone, but Bismarck has the longest continuous records in the state of North Dakota. So I like to use it. But you'll notice on June 26th, down here in the corner, and if you look carefully down here, this usually has 4 lines on it: the high, the low, the normal, and what's currently happening this year. But on June 26th, Bismarck was the driest on record of any year. And the records in Bismarck goes back to the fall of 1874. So yeah, by the end of June, Bismarck was drier than 1936, 1934, 1988. Some of these years that are in the memory book of a lot of people for phenomenally dry years. It was that dry. And during that time frame, I was getting a lot of phone calls. And I said, well, on a positive note, it does look like we're going to get a little bit of rain in spots, in the month of July. And hopefully that could make up some of these deficits. Well, some people got hit and others did not get hit, of course, during that time frame. But this is now Bismarck through the entire year going forward. So what happened was, yeah, there was a little bump up in Bismarck, but Bismarck, northwestern North Dakota, eastern North Dakota, really most of South Dakota, Minnesota, all of the northern central part of the United States really just went through this period now of almost 4 months of very little precipitation. So Bismarck in turn finished with the 3rd driest year on record. Again, the only years before that were really back in the 1930s. And the thing is, even in Williston's records, which don't go back quite as far, but it's a kind of Bismarck, Williston's records rather is in many ways a mix of a bunch of different record sites. And of course, now the airport's been moved even farther away from the city for the official records. But you notice there's this little bump in July, but then same thing, is almost all areas just almost flatlined for the last 4 months of the year. Williston also ended up with the 3rd driest year on record. So it was a phenomenally dry year in some areas, but not necessarily as widespread dry as, say, we saw in the 30s or even in 1988 in many areas. So this was the percent of normal precipitation for the stations that we had up and running on our main website this past summer. And this is percent of normal. So 100% would be exactly normal. So generally on this map, if you're in the yellows or oranges, you're below average. In the green, above average. And you notice there's some dots in western North Dakota, northwestern North Dakota. A lot of those little areas, and some of you may recall this, back in July, in the first part of July, we had a thunderstorm complex that came through that dropped anywhere from 3 to 5 inches of rain, some isolated spots even above 5. Of course, when it comes, that's half your summer average rain comes in one day. You get a lot of runoff. A lot of it doesn't necessarily absorb in the soil. Yeah, it's better than nothing, but sometimes it was too much. But of course, that thunderstorm complex that day did not necessarily hit all areas. So that happened in July. So if we just focus on the summer, June, July, and August, that's why these areas finished with above average rain during the core of summer, June, July, and August, and other areas didn't, was again, generally speaking, from one precipitation event. You notice off to our east, same thing, got quite a bit of rain, especially in July last year, but generally speaking, even those areas finished the year with below average precipitation. Here's temperature wise, and this is from the current averages. You notice either a little bit above, a little bit below. Most of western North Dakota was fairly close to average for temperatures for the entire growing season, if we can count May all the way through September on all of that. But if we take the core of summer last year, the summer was pretty warm. There's some parts of eastern North Dakota that had one of the warmest summers on record, believe it or not, but it never got really hot. There's a couple of hot days in western North Dakota, but generally speaking, it wasn't a summer with a lot of extreme heat. A few days, but not very many. Usually years that are finished above average is because we had 4 or 5 days, like 102, 103 type days. That really didn't happen in most places. Few spots it did, but not most places during the growing season last year. So that's just really a quick summation of 2020. This was the climate divisions. I show this map for May through September 2020. Generally, as I'm going to show what I think is going to happen in 2021 on a very similar map. And you notice North Dakota is divided up into 9 counties, 9 zones, and I think Montana is in 9 zones as well. And this is how, say, NOAA the National Oceanic and Atmospheric Administration, say the National Weather Service, divides up in the country. And no surprise that May through September, generally most areas were dry. Few spots were close to average or a little bit above, but all in all, it finished off to be a dry 2020. So then the big question is, for many people, is, will this continue into 2021? Now, before I get into my forecast, I wanted to show you this graphic, because what I just did to you is gave you some maps that talked about the average. What exactly is an average? This might be a reminder to some of you, but also to pinpoint something here, that if you have rainfall insurance, rain insurance, then this might be a big factor for you. Now, averages from the World Meteorological Organization, which NOAA, the National Weather Service, follows these guidelines, is that an average is the last 30 years in whole decades. And decades end in zeros, not nines. So on December 31st, 2020, the averages for the United States, every place, was based on 1981 until 2010. And so those averages we've kept for the last 10 years. Well, guess what? It's 2021 now. So on January 1st, all the averages technically switched to 1991 until 2020. What does that mean? Well, every 30 years in whole decades, and these are the whole decades, this is when they end, is when the averages changed. And so Fargo and Bismarck actually have averages way back. Most areas like here in Williston and other areas nearby really didn't have a full 30 years of data until 1930. But look at how the averages changed. For instance, not relevant to many of you, but Fargo jumped a whole inch. You'll notice Bismarck, the average is going to go from just under 18 inches to over 19 inches. The average jumped over an inch. Here in Williston, we jumped about 3/4 of an inch for the new average. Dickinson, very little change, but down in Bowman, the average jumped over an inch. So this comes down to rainfall insurance. If you get rain insurance, in turn, you're going to have to ask, is this based on the old averages or the new averages? Because the averages went up, but the averages does not really, to me, summarize, I should say, the entire period of record. I'm personally, been involved in meteorology for over 30 years now. I've always been a big fan of really using the long-term average, because the 30-year average is kind of, well, yeah, it's been a little wetter now, but that doesn't mean we're always going to stay this way. Or say in the 1980s, well, yeah, we've been dry for a while, but are we always going to stay this way? I like looking at the long-term average. Just to use Fargo as a reference, because I have this memorized in my head, but this new average in eastern North Dakota around Fargo, of the 140 years of records in Fargo, only 40 of them have the rainfall amounts been higher than the current average. 100 of them has been below. And so that percentage, it's like 75% of the time, is very likely true for all areas, because our average rainfall has been skewed up a little bit, because what I would describe, not all areas, but most of the northern plains have really been in what I describe as a wetter phase of our all overall long-term climate. You go back through proxy data, there's been wet periods, dry periods, more average periods. It's just, the weather works that way. Everyone likes to put linear lines on weather trends, but the weather doesn't act in a linear fashion. It's just kind of made up sometimes. So anyway, I wanted to point that out, that this year, new averages are going to come out, and our temperature data is going to change very, very little. We replaced the 1980s with the 20 teens. So your average frost dates, your average temperatures really are going to change very, very little. But many locations, and again, Dickinson is one of those exceptions, not there, but in many areas, rainfall averages are going to go up. But that doesn't mean our climate has changed. We still live in a semi-arid place where rainfall is always, more often than not, a precious commodity. So I just wanted to point that out. So I wanted to just take a quick look at something, looking at what I think is going to happen in 2021 and maybe beyond, is that, we don't have a lot of areas that, and I was going to show you the Burr Oak stuff, but I was going to skip through that. This is off to our east by quite a ways, but I still like to show you that this is the Great Lakes water levels. And you will notice that Michigan and Huron are really kind of the same elevation. So they actually have Lake St. Clair. If you're unfamiliar with this lake, it's kind of a smaller lake, but it's the bigger lake that's by Detroit, the city. And so they have a level for that. But really what I wanted to show you is the level since 1918. And you'll notice every once in a while on this graphic, you get a little bit of a spike up. One of those spikes up occurred right there. That was in the late 1920s. What happened in the 1930s right after that? Correct. You're all thinking the same thing. Here was a spike in the early part of the 1950s. Now, North Dakota, eastern Montana had distinctly some dry years in the late 50s, early 60s. But if you go south, you go down southern South Dakota, and especially you go to Nebraska down through Texas, that's more the central and southern Great Plains, they really had some 1930 type droughts again in the 1950s. It wasn't as severe where we are, but they were still followed by some drier years. Here's another line in the sand. This was in the early 1980s. What happened in the late 80s, early 90s? Yeah, that's the drought, last long-term drought of more than, say, a couple of years that many spots in the United States experienced. Well, guess what? Here we are in the late, 20 teens to 2020 now, that we peaked again. So if history is our guide, what would you think might be coming up as we go into the 2020s? It doesn't mean that this is going to follow. It's just something that I like to show people, that I'm a big fan of the history not repeating itself, but history to me rhymes at times. Tom Sawyer is credited with a lot of famous quotes. And one of his quotes that is oftentimes used is, history does not repeat itself, but it does rhyme. I like to take the word history and change it with weather, because weather never repeats itself, but it does oftentimes rhyme. And it's very interesting. I had someone from Western North Dakota a couple of days ago talk to me about the 1930s. And he said, I just have this feeling based on another stuff that we're, kind of due for something like that. And I talked to him about the Great Lakes and some of the other things I've been talking about too, that I told him, neither one of us knows the future, but I said, I don't think you're crazy and you're thinking that perhaps a drier phase is coming up eventually. So to look at 2021 specifically, the next, say, 6 to 9 months, I always, if you never heard me speak before, I always like starting with the oceans. Why? The oceans are 70% of the planet, number one. And number two, the oceans contain almost all of the heat capacity of the planet. It's not in the atmosphere, it's in the oceans. So this map here, the key word here for you to focus on is anomalies. It's not temperatures. Are you above or below average? Red areas like the North Pacific, above average. The equatorial Pacific Ocean here, blue, is below average. But I will remind you, the water is warm here and very cold here. It's just above average. So just keep that in mind when you look at this map. The thing that probably sticks out the most to people when they see that is what's happening right here. That's the La Nina that most of you have probably heard about. Most of you probably also heard last fall, oh, there's a La Nina, so it's going to be a cold and snowy winter. When I was interviewed about that, I go, there are some examples of cold and snowy La Ninas. And in turn, if you lump all the La Ninas together, statistically, they tend to be colder than average, but there's a lot of very warm La Nina winters. Matter of fact, the La Nina in 11-12, which is not in all areas, but in many areas, the warmest winter on record, occurred during a La Nina. So again, I always tell people, La Ninas are not good statistical tools for winter forecasts, as well as, say, El Nino, the exact opposite. And I also remind people, anytime you hear that, say a La Nina equals drought, or La Nina equals cold, or La Nina equals anything, that's not true, because no one thing controls the weather. I wished it was that easy. I've been doing this for 30 years. So in other words, X does not equal Y. It's usually, that's TUVWX equals Y. There's usually several factors. Now, I will be the first to admit this going on in the Pacific right there is probably the biggest factor globally right now. But again, it's not the only factor. And there's a big difference in thinking that way. Sometimes people try to very much oversimplify the complexity of the atmosphere and the weather. So a La Nina by definition is the equatorial Pacific, a half a degree Celsius. Think of it as 1 degree Fahrenheit, colder than average. And an El Nino is a half a degree warmer than average. What I did not throw in this definition is over a 3-month period, because it's not a weekly thing. It has to be kind of consistent for several months in a row. This is just a couple of examples. This was the La Nina we had 3 years ago in 2018. This was the El Nino when, if you're old enough, say 50 or older, first time you ever heard the word El Nino was because of this event back in 1982 and 83. So 82, 83. But notice the water temperatures elsewhere around the planet during these phases. Not really looking anything similar necessarily to what we're seeing right now, but what's happening in the equatorial Pacific, this is a couple of examples for you going forward. So it's really in these rectangles that I'm drawing is where El Ninos and La Ninas are measured. So it's in that area in particular. And there's actually zones with El Ninos and La Ninas. And it depends, if the cold water is here, North Dakota, Montana will get different weather than if the cold water is here, or vice versa. If the warm water was centered here, we tend to get cold winters. If the warm water is centered here, we tend to get warmer winters with El Ninos, exact opposite. But again, every time you hear El Nino, everyone forecasts, it's going to be a warm North Dakota winter. No, that's not the case. It depends where things are situated in time. So you have to make these examinations. So this is model predictions. Down here is that 3-month period. And I'm circling that because that's June, July, and August. That's the core of our growing season there. Or at least the beginning, starting, in May, June, July, and then going forward. But here you notice during the summer, most of the models still have us in that area right there, which is still a cool water. And usually under those circumstances, in combination with a couple of other things I think is going on, will equate to a certain type of weather pattern over the center part of the North American continent, which of course is where we live. Now, this is El Ninos and La Ninas for the last 70 years through 1950s. All of these are El Ninos, which I described earlier. This is warm. And here are the current La Ninas. And of course, what I just circled there, that was back in 88, 89. And so that was, La Nina in 88, big drought. Why wouldn't we elsewhere in time? Sometimes it works, it doesn't. It's hard to see at the end of this, but right here is where we're at right now. And if you notice, if you go back through time, this is one of the stronger La Ninas that we've had, at least in the last 70 years. So it is pretty significant, much, much more significant than the last couple of weaker La Ninas we've had in the past decade. So this is really the strongest one that we've had in the last 10 years. So one of the many tools I use in forecasting seasonally like this is to look back in time when were situations similar to today, and in turn, what were some of those other factors? Because this is just looking at the X equals Y part. And again, it's not that simple. What are some of the other factors going forward? Were they also similar to what they were this year? Now, one thing that a lot of people have been talking to me about lately, although this cold snap has quieted that down a little bit, is, wow, Daryl, this winter is almost exactly like 11 and 12. And wow, 12 was a widespread, really the last widespread drought in the United States. There's been regional droughts. We've been in dry periods in Western North Dakota since then, yes, but more nationwide. And I go, well, here's the thing. Notice back in 2012, this cold pool off of the west coast of the United States, this year it's warm. There's this concept called the Pacific Decadal Oscillation, which I think I mentioned the last time I was at the wheat show in person, that it has a big influence. And oddly, everyone ignores the Atlantic Ocean, but the Atlantic Ocean also has influences on especially rainfall more than temperatures in the northern Great Plains. So in turn, you have to look at what the scenarios are. The Atlantic Ocean is somewhat similar to what we had that the last widespread United States drought, but the Pacific Ocean is completely different. So could 2012 and 2021 be very, very similar? Absolutely. No one knows the future. The thing is, if it is, it's for different reasons, again, than it would be. It's just, again, it's more complicated than just looking at one particular source going forward in time. So this is that Pacific decadal oscillation. This is a concept called the Atlantic multi-decadal oscillation, but really this is an alphabet soup for you. I just want to show you that these are a whole bunch of phase changes that occur globally. And you notice most of them end with the letter O because they're oscillations. Some of these last 2 or 3 weeks on average. Some of them last 2 months. The ones in the Pacific and the Atlantic Ocean, these two, they have the word, this is multi-decadal, and this is decadal in the middle. They last, in a decadal period, which is a decade. Sometimes they last a decade or longer through times. But there's good research that suggests what these two are in combination have not 100%, nowhere near that, but greater than a 50% probability that this year is going to be X or Y based on what those two phase changes and a couple of other things in research. So it's all of these factors combined that you really have to look at when you're trying to forecast long term. So this is just my all-time running joke. This is me sitting in a DeLorean. Sadly, Back to the Future has been 30 years plus already since that first movie came out. So a lot of people don't get this, but this is Back to the Future joke of going back and forth in time, trying to forecast the weather. But looking at analogs, and analogs are, again, years in the past that have been very similar to what's happening now, both oceanically but atmospherically. And I will say in 2012, we did have a cold snap, but not like this one. Again, the oceans aren't quite the same. Really, that year, 11-12, is not in my analog set, believe it or not, although the winters until about a week ago were pretty similar. So really what this is 4 years in the past combined together, and it comes up with this for temperatures. And you notice they have most of the Great Plains above average. The overall average was just slightly. I personally think 2021 is going to be cooler than 2020, not necessarily cold, cooler. Here's the thing, it depends on what crop you were growing last year, but we had, of course, just a devastatingly early freeze last year on September 8th, 9th. Generally, most areas, North Dakota, Eastern Montana, South Dakota, Minnesota, all had a very early hard freeze. Just statistically, you don't find two really early hard freezes back to back in history with what little records we have for 100 years. So I would not be surprised if we get just as many growing degree day units next year that we did in 2020, but just it will take us longer to do it because we'll be a little bit cooler. And then for wheat, especially spring wheat, you'll probably might be just a smidge lower if this worked out perfectly. But the reality is, I think in those situations, it's going to end up being very, very similar for growing degree day units. Now for precipitation analogs, these years in the past, which similar patterns, it has the northern Great Plains drier than average. And look up here, this is the 1981 to 2010 average, not the new average going forward. But if you look at this map very carefully, if you've been paying attention to the weather in the last really 3 months, you notice this area that my analogs have wet this upcoming summer has been where it's been wet for the last 2 months or so. Where my analogs have it dry, we've been dry. The one exception is this area up here has been wet this winter. But again, this is a summer forecast. So in some ways, the pattern we're seeing right now, my analog package at least is suggesting that it may continue into the upcoming summer season. So this is a reminder, this is 2012 and 2017, even in extremely dry years, we get all of our, not all of it, but a vast majority of our precipitation comes from thunderstorms. And even if my forecast comes true, and I wouldn't call it a forecast as much as my analog package being correct, you're still going to have spots that do much better than other spots. And of course, there's going to be spots that do much worse because it's just the nature of the randomness of thunderstorms. So really, in a nutshell, in one final last page, to me, there's just reasons to think that the dry that we're currently in will continue into 2021. Parts of Western North Dakota were extraordinarily dry in 2020. Would those areas be extraordinarily dry again? Probably a few spots, but probably not all the spots. There's different levels of dry. There's being 1.5 inches below average or being 3 inches below average. We live where above average is good most years, not every year. Sometimes it gets too much, but rain's generally speaking is a good thing unless it's timed poorly when the wheat is flowering, of course, heading out. But again, I think the analog package, what's happening globally right now just seems to suggest to me that there'll be more dry than wet areas in 2021. Every year I forecast dry. I always say, I hope I'm wrong. I think the colder weather that's in place now will kind of last through March and April, where there will be more below average periods than above average periods. But I think then as we get into the core of the growing season, we'll be average, maybe a smidge above, just probably not quite as warm in a lot of areas as what we saw last year. And then again, want to remind everyone of not only the decadal changes to our precipitation mean that I described to you, which just is happening now, just from our averages, but also, looking at the long-term phases for the last 130, 40 years, we've had a little bit more wet than dry, that probably, I think still that we'll probably go back to that 20th century mean, which might be an inch less moisture than we've been getting the last 10, 15 years, or 2 inches less than the last 10, 15 years. That type of average at some point will come back. It's just a matter of when rather than if, to me. Just a matter of when. So anyway, that's a brief summation of what I think going forward, a little bit of end on. There's my email address. You're always very, very welcome to get a hold of me. I'll take myself off of that and just put my face back up, and I'll be very happy to answer any questions if anybody had one. I don't see anything in the chat either. So Claire, any questions for me, or otherwise I can just let you guys take over and move on.
Yeah, Daryl, we
now
have
you're back to feedback. But go ahead.
I guess I was thinking with the minimum snowfall we have in Western North Dakota, isn't it going to warm up faster? Because that's usually the case.
It is usually the case, but if you have a cold air pattern, I mean, look at this morning's lows, for instance. Many of you in Northwestern North Dakota were down close to 30 below this morning. Guess what you would have been if you had 6 inches of snow or 7 inches of snow on the ground? Probably 40 below. So the snow does have an impact, but you can still get below average going forward. And it only would take, say, a simple 3 to 6 inch snowfall on March 4th. And then you have a snowpack, and then it's a cascading effect through that. So it's really no moisture much there, but it would be enough to cool you down. So you're absolutely right. It would help you a little bit, but I still think that would be more of a help in April than in March. And clearly I'm forecasting the future. I could be completely wrong. It just looks to me what's happening is that this cold period, and it's not going to be this cold, 30 degrees below average every single day, no way. But, just more below average than above average days going, say, for the next 60 days going forward. But if that even works out, and if we warm up, we don't have much snow going forward into April, you're right, the lack of snow goes on. But a lot of years when we've been dry in the first half of winter, there are examples at the high plains, Western North Dakota, Eastern Montana, tends to get a late season snow event. The positive of that, if you're a rancher, you get your first hay crops, awesome, because you have all that moisture soaking in. But at the same time, if you're growing wheat at the same time, it might slow you down spring planting. So a lot of times in our climate, just telling you what you already know is one storm in April sometimes is a huge difference in what happens, then for that entire month of April. But I just think there's just reasons to believe that be more cold there than warm. But you're right. As long as we keep snow away, the faster opportunities we have to warm up.
Thank you very much, Daryl. We will, applause from the room and applause from online. Thank you.
Hey, you're very welcome. And again, I hope I'm out there next year. And again, we have a lot of end-on stations coming online for all of you. And if you have any questions on that going forward, please let me know. And again, I'm quite confident that most of those stations that aren't online will be. And so, for our fusarium head blight or scab model this upcoming summer, for all those stations online, we should be able to pinpoint conditions pretty good this upcoming year. So again, don't be afraid to give me a call if you have any questions. Otherwise, thanks for having me today. Appreciate it.